So here we are on to question 4, complex numbers. Not everybody likes complex numbers, but I must say I always think it is a good question for students to have in the bank as such, because it's almost a guaranteed short question. And with practice, there's only so many stuff they can ask. So in this case, it says we have a function here, pz is equal to z minus 2 times z squared minus 10z plus 28. Where z is equal to a plus bi, a and b are real numbers, I squared equals minus 1. Solve pz equals 0. And again, as we mentioned earlier, how do you solve any equation? You isolate the variable. In this case, the variable is going to be z. Give any complex solutions in third form. So the easiest thing is to start off. We have two things multiplied together equal to 0. The only way that can be true is if at least one of them is equal to 0. So z minus 2 could be equal to 0, meaning z is equal to 2. And z squared minus 10z plus 28 is equal to 0. So that's a quadratic equation with a variable z. What we're going to do is we're going to do the minus b formula. Of course, it's a complex numbers question, so we assume we're going to end up with complex numbers. And we do because we get a negative underneath the square root. We get a negative discriminant. So we get minus 12, negative 12, and the square root of negative 12 can be written as the square root of negative 1 times 12. We know the square root of negative 1 is I. That's where the I is coming from. And the square root of 12, so maybe I'd write it like this. It'll be root 4 times root 3 times root minus 1. So the root 4 gives you the 2. The root 3 can't be simplified. And the square root of minus 1 gives you I. So it's 10 plus or minus 2 root 3 times I over 2. We can divide the 2 into the 10 to give us 5. The 2 into the 2 times root 3 to give you root 3. So your answer is 5 plus or minus root 3i. So you could say the solutions are 2, and you can say if you want 2 plus 0i. So we could say z is equal to 2 plus 0i, z is equal to 5 plus root 3i, and z is equal to 5 minus root 3i. And those are your 3 solutions. So that's 10 marks, and I think, relatively straightforward. We're going to plot them on the Argand diagram, so the 3 solutions. So here is our 2, 0, our 5 plus root 3i, and our 5 minus root 3i. Then we're asked to verify that these 3 points form an equilateral triangle. So you will see that like these basics of geometry can slip into paper 1, kind of, in little places just like this. Nothing too difficult about it, but you just got to use coordinate geometry to get the distance from A to B, which turns out to be 2 root 3, from A to C, which turns out to be 2 root 3, and from C to B, which turns out to be 2 root 3. And then, of course, we'd be hoping that everyone knows what an equilateral triangle is, that all 3 sides are equal. And in this case, that is certainly true. So we have 10 marks for that. And then the last part is if z1 is equal to 2 times cos pi over 6 plus I times sine pi over 6, and z2 is equal to 3 cos pi over 3 plus I sine pi over 3, calculate z1 times z2 and give your answer in rectangular form, where a and b are elements of the real numbers. So again, with this, you just start off. If people are familiar with polar form and have practiced it a lot, they'll know that when you multiply 2 complex numbers, you multiply the moduli together, so 2 times 3, and you add the arguments, which are the angles. So the pi over 6 gets added to the pi over 3. So you get cos pi over 6 plus pi over 3. And the exact same for sine. You're adding the pi over 6 and the pi over 3. So you get pi over 6 plus pi over 3. And you get 6 times cos pi over 2 plus I sine pi over 2. And you do have to remember to get this in the form that's asked. Otherwise, you're not going to get full marks. Cos pi over 2, well, that's the same as the cos of 90 degrees, which is 0. And the sine pi over 2 is the same as sine of 90, which is equal to 1. So basically you have 6 times 0 plus I, and you multiply it through 0 plus 6i. And that is your final 5 marks. So with complex numbers there, you could see that if you were good at it and well practiced and understood that little bit there about polar form at the end, it certainly was a straightforward question for you. So that's question 4 done. Let's move on to question 5.